Hello, this time we will use not this display, this time we will use this 4-digit display. Okay, 4-digit display, and I will again start to build this. We'll again change the setup here. Yeah, you know this setup, we've used it previously. Now I'm going to use this display. Okay, we'll start to change the hardware setup. This is how I'm going to change it. Okay, however, not yet. So these lines, these ones to the output, I'm not going to do. I will all connect them to ground, to blue, to minus. Okay, so this will happen. Okay. Meanwhile, the original Heinz is going to explain this device. Okay, so let's start. Once again, let's start once again. This one out. Better. So this is this device. Yeah, pretty much the same display like we used before, but this time we are using a 4-digit 7-segment display. Okay, so we have 4 times 8 LEDs, and if we turn it around, there's not that much connectors, right? There are only 12 connectors. How is this then possible? I mean, there are only 12 connectors. On the other thing, we had 10 connectors. So at least there are 2 more. But it's not just 1 digit. It's 4 digits. Okay. So how is this working? It is working pretty simple, I would say. Yeah. So it is working. This is the display. This is from the datasheet. You have the datasheet on your CD in your starter kit. Here we have this 1, 2, 3, 4-digit display. Yeah, our display does not provide this D5 and D6, these points. It just provides the decimal points here. Okay, and below here you see how the LEDs are connected, and you can see if you want to light up line A, that's the top line, yeah, on digit 1, you have to connect to 11 plus and to 12 minus. Yeah. Then this LED here, this one, is this LED here is starting to light. Yeah. However, if you set 11 plus to 11, yeah, then also, and the A on the 2nd digit and the A on the 3rd digit and the A on the 4th digit, they are all connected to each other. Yeah. So if there's 11 a plus, yeah, all of these A's will light. If all of these grounds are connected to ground. If they are not connected to ground, if they are open, yeah, then this will not light. Okay, so this is how it is possible. We do have 1, 2, 3, 4, 5, 6, 7, 8 for our 8 LEDs, and then plus 4 is 12, 4 ground, and 1 ground for this digit, 1 ground for this digit, 1 ground for this digit, 1 ground for this digit. Okay, so that's how this is, how this looks like, how this internal connection is done. Yeah? And now it's clear. Yeah? Now it's clear why we can control 4 digit with only 12 pins. Okay, that's it. Yeah, yeah. I hope the original Heinz is already done with the hardware setup. Okay, I think this looks good. Yeah? Plug it in. There was quite some light. Let's see. Good. 3 is not perfect. 4 also. So it seems like I mixed up the middle with the decimal point. Okay, what does this mean? Middle with decimal point mix up. Decimal point is 3 and the middle one is G5, 3 and 5. 1, 2, 3. I will enter digit numbers. I will enter digit number 3. Okay, the decimal point is gone. You see, if I plug it in here, this is obviously the decimal point, and this black one here should be 3 and 5. This one should be the other one. Let's mix them. Okay, looks better. 3, 4, 5, 6, 7, 8, 9, 0, 1. Good. Working. But as you can see, all digits do display the same value. This is because I only have 8 inputs, and these 8 inputs are connected to every LED. If we are looking on the schematics, here they are. You see the pins 3, 5, 10, 1, 2, 4, 7 and 11 are connected to every digit, and these are the grounds 6, 8, 9 and 12. Okay, so every LED is lit. Yeah, every time the same. And if I do not want that each each digit is lit, see what happens if I remove here this one, then this first digit is going off. If I remove this one, the second digit is moving off. If I remove this one, this digit is turning off, and if I remove this ground, this digit is turned off. Okay, so what we need to do if we want to display different values here, a 4-digit number, then we have to put these things on outputs. We have to put these things on outputs, and if I set the output to low, I will control this digit. The other ones are set to high. Okay, then I will round robin, set this to low, write what I want to write here. Set this to low, write what I want to write here. Set this to low, write what I want to write here. Set this to low, write what I want to write here. Okay, and so it will then always flashing. One time I will write this letter, then this letter, then this letter, then this letter or digit, yeah, and so it will blink, but it will be too fast for our eye to visualize. Yeah, we will see what the camera is doing, so then we can write 4 different letters. But the trick is this multiplex, it is called. Okay, so we are multiplexing. We only write one letter after the other. Okay, this is why we originally had these lines here. Yeah? This is going to digital outputs, and if they are low, I will control the corresponding letter. Okay. Basically, if you have come this far that this is working, you have it connected correct. Yeah. If you want to do it a little bit more sophisticated, you can try to write a letter you like. Okay, so and this is how it should look like. This time it is really slow. Okay, so you see we're writing one digit after the other. I made it really slow. Okay, I have a delay in my program, and I made it that slow so that we can observe what is happening. Okay. So I will now type in 1, enter. See, first digit is 1, second, these are still written 0. 1, 0, 0, 0, 1, 0, 0, 0. And if I type in now a 2, yeah, then this one is 2, this is 1, it got shifted, 0, 0. Yeah. If I type in now 3, yeah, 3, 2, 1, 0. Okay. But you see, we cannot read it really. Yeah. So I show you the portion of the code where this is happening. Yeah. This is this one. Yeah. So I set the old pin to high. Yeah. So then the digit goes dark. Then I say okay, next digit, and this percent is a modulo, so it's the rest of a deviation. So modulo 4 means I divide whatever is there with 4. Yeah. So this value is now between 0 and 3, because if it's 0, it's 0. If it's 1, it's 1. If it's 2, it's 2. If it's 3, it's 3. If it's 4, it's again 0, because the rest of the division, 4 divided by 4 is 1, rest 0, again 0. So this is between 0 and 4. This is done quite often. Yeah. Then I update the shift register, yeah, with the corresponding pattern of this digit, yeah. And then I set the LED, the output to low. So then this gets displayed. Yeah. So once it's getting dark and the next thing is displayed, we shift it out. Then you see how fast this is really going. Yeah. I solved it that way, that I used arrays. Okay, what is an array? An array is, I now just don't use one byte, I use 4 bytes. Yeah, and within these brackets I can select which value I want to have. So I have a size of 4. This means I can have 0, 1, 2 and 3. Yeah? And this I'm filling up here. This is why it's written here late, and this bracket, This is what it means. Yeah, you can look it up in on the Arduino homepage, Arduino CC reference. Yeah, and you do have here array, data type array. Okay, here you got the explanation how an array is working. Look into this, it can help very much. Okay, so this is also what I've used here. Okay, the serial read I've adapted. Now whenever there is a read in something between 0 and 9, I just copy what is in LED number 3, I copy to LED 2. What is in 2, I copy 1. What is in 1, I copy 0. And if this is done, there's a for loop, we had already for loop. Yeah. If this is done, yeah, then I add at 0 the new number. This number here, these numbers, I also made these numbers. It's also an array, you see it here. Yeah, and this is holding for digit 0 the bit number of 0, for digit 9 the bit number of 9. And here you see this is the bit representation of 9. Okay, this is how I solved this. Yeah. This B means binary. I could write there as well a decimal number, but with this B, for me it's easier. That's the decimal point, that's the middle point, and so on, and I select which one should be lit. Okay. Yeah, and these pins I have selected 4, 5, 6, 7. These are the hardware pins I've used here. Okay. Like I said, this is very sophisticated. If you're had it the way that every digit has the correct number, it's already fine. This is already something for the good ones. Yeah. So don't be too I don't know, sad if you don't fully understand what I try to tell you. However, here you see this is this delay 1000. This is why only every second we hop to the next. If I just remove this delay, what is happening? What is happening? You see, it's very, very dark. You can only imagine that there is something written. If I say 1, 2, 3, yeah, it's very dark, very dark. It can just not be seen. 5, 6, yeah, you can guess, but that's not really nice. Why is that? Because it's getting turned off and on so fast. It's too short lit for my eye or for the camera. I cannot see it. Okay, so 1000 was too high, 0 is too low. Yeah, so I select here simply a value. Let's try 50. 50, download. What is happening? It's flickering, but it looks already much better than before with this one. If I type in something here now, 1, 2, 3, yeah, it cannot really be read because it's too flashy. Yeah, it looks a little bit like in the club. Yeah, flashy. So this is still too slow. I will use here 5 now, or let's use 7. I don't know. Download, upload. What is happening? Yeah. For my eye, it looks flickery. With the camera, we still see it blinking. Yeah. For my eye, it looks very flickery. 1, 2, 3, 4. It's getting better. Yeah. But for my eye, it's just flashing. It really hurts my eyes. For the camera is faster than my eyes. You even see them still blinking. So let's why not use 2? Huh? Even smaller. What is happening? Okay, for Maya it looks very stable, and even for the camera we are now fast enough. Okay. 1, 2, 3, 4. Here we go. Okay, good. Yeah, this and x. What happens with x? Not totally correct. Yeah, the last digit is not deleted. And there's still a little error in the code. It is here. It should not stop at bigger 0, bigger or equal 0. Upload. One, 2, 3, 7, x, 0. Wundervoll, wunderbar, 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 wonderful. Yeah, that's it. So fast. Okay. If you could understand what we are doing here, yeah, you're fine. You're absolutely fine. You're in a very good way. Yeah, this is called multiplexing. It's very often used, very often used to reduce simply the power drain. So here we are using the same amount of power like we would only use with one digit. Yeah, just because we turn it off and on that fast after each other, we have only 1/4 of the power usage. It's also a big advantage. Multiplexed output. Yeah, so that's it for this digit, for this display. Next time we are going to talk about if we want to display even more data. In our Arduino starter kit, we also have this thing here, LCD display. Next time. This time, thank you very much for listening. Goodbye.